Welcome back to the video series on integration and differential equations. In today's video, we're going to explore inverse trig forms. Here are the two key formulas for this section. We've got one integral that produces an arcsine term plus a constant, and our second integral produces an arctan expression plus a constant. So in looking at these two integrals, let's just notice a couple of differences. First of all, in the top integral, we've got a square root in the denominator, whereas the second integral has no square root, so that's one difference. Second difference is that the top integral has a minus sign between the quantities under the square root, whereas the second integral has a plus sign between the two quantities in the denominator. So those are the two things we'll be especially watching out for when we're applying these formulas. The number, or the expression a in this context, can represent any real number other than 0. So let's try a couple of examples. Here's our first example. We've got the integral of dx over square root 49 minus 11x squared. Well, we're seeing a square root in the denominator, which tells us it's going to be the top formula here. So let's see if we can write this denominator to make it look like exactly what we've got in the formula. So we'd like it to look like square root of a squared minus u squared. That way we can get this integral into the correct inverse trig form. So first step, let's take a look at the denominator here. We'll recopy the square root and let's write each of the quantities in that denominator as a square. So we'd have 7 squared under the square root. We've got 7 squared minus, and then something else squared. What needs to go in the square here is root 11 times x. So let's just do a double check here that if we square this quantity, the root 11 will be squared to give us 11, and the x will be squared to give us x squared. So yep, this second expression here, that does equal 11x squared. Great. So now we're ready to make a substitution. Let's sub u equal root 11 times x, and that would make du equal to root 11 times dx. Okay, so if we look back at our last step here, we're going to be able to rewrite that denominator in the correct form, and what we'll have left over is the dx. So let's move from this step to this step by dividing by root 11. We could say du over root 11 is the same thing as dx. Now we're ready to go ahead with our substitution. So let's replace that dx with a du, and we'll put the 1 over root 11 out in front of the integral. So there we go, du over root 11, same thing as dx. And in the denominator, we've got the square root of 7 squared minus u squared. So this now exactly matches the arcsine form, the first integral that we introduced here. So according to our formula, we're going to get 1 over root 11 times arcsine of u over 7 plus a constant, and to get our final answer, let's just go back in terms of x. So remember, u was really root 11 times x, and there we've got our final answer. I've recopied our two key formulas so we can take a look at them, and let's try a second example. This time when we look down at the denominator, we are not seeing a square root, so we're going to be using this Arctan formula here. First thing let's write the denominator in the correct form. So according to our formula, we'd like our denominator to look like a squared plus u squared. So let's recopy our integral. We've got cos x dx on top. On the bottom, let's write 4 squared plus, I'm going to write sine squared x as sine x all squared, just so we can see explicitly what quantity u is taking on. Okay, so now our denominator looks like the correct a squared plus u squared form, and we can do our substitution. So let's sub u equals sine x. That would make du equal to cos x dx. And if we look up at our integral here, we're in good shape. This numerator here is just going to become du, and the denominator we're going to be able to write as a squared plus u squared. So that looks great. Subbing in here, we've got du over 4 squared plus u squared. That's what's inside our integral, and that exactly matches the Arctan formula that we introduced earlier. So applying this formula, we're getting 1/4 arctan of u over 4 plus a constant, and final thing we need to do is just go back to our original variable. So instead of writing u, we'll write sine x. And there we have our final answer. Thanks for watching, and we'll see you in the next video.